Let's imagine that you are the CEO of a company with two divisions. One makes markers and the other makes notebook PCs. The marker division reported that quality is at 2 defects per unit. The PC division also reported a quality of 2 defects per unit. Are the two divisions performing at the same quality level? The answer is no. In this movie, I will discuss a more accurate way for calculating performance, using the concept of defect opportunity and a metric called Dpmo, or defects per million opportunities. Let's continue with that example. How many things can possibly go wrong in a marker? Perhaps 5, such as the pen can leak, the cap doesn't stay on, the ink color is wrong, and so on. These possibilities for defects in each marker are called defect opportunities. So let's assume that there are 5 defect opportunities per unit for the marker. Now, how many things can possibly go wrong in a notebook PC? The notebook PC is a lot more complicated than a marker. There are many more opportunities for defects. Looking at the number of components and functions in a notebook, the number of defect opportunities is definitely more than 5, much closer to 1,000. So for the sake of illustration, let's say there are 1,000 defect opportunities per unit. To summarize, a marker has 5 opportunities for defects, while a notebook PC has 1,000 opportunities. Let's compare the reported 2 defects per unit. Say 1,000 units were produced in each division. That means there were a total of 2,000 defects in those 1,000 markers and 2,000 defects in the 1,000 notebook PCs. Defects per opportunity, or Dpo, is the total number of defects divided by the total number of opportunities. For the marker, the numerator is the total number of defects, which is 2,000, and the denominator is the total number of opportunities, which is 5 per unit multiplied by 1,000 units, which equals 5,000. When we divide 2,000 by 5,000, we obtain 0.4 defects per opportunity, or 0.4 Dpo. To convert to Dpmo, we multiply by 1,000,000 and we obtain 400,000 Dpmo. For the notebook PCs, the total number of defects is 2,000 also. The denominator is 1,000 opportunities per unit multiplied by 1,000 units produced, or a total of 1,000,000 opportunities. When we divide 2,000 by 1,000,000, we obtain 0.002 defects per opportunity, or 0.002 Dpo. To convert to Dpmo, we multiply by 1,000,000 and it is 2,000 Dpmo. The performance of the two divisions are very different. Based on our example, 2,000 Dpmo is very different from 400,000 Dpmo. Using Dpmo as a measure of quality is more accurate than using defects per unit. So back to our CEO example. Comparing both divisions by defects per unit is misleading. The PC division is performing at a much higher level of quality than the marker division. We can only arrive at this conclusion by using Dpmo. And that's why we use Dpmo in Six Sigma.